So before we're going to be looking at logarithms, one of the things that I want us to focus is the way we're going to read this is y equals log base a of x. We can write this as an exponent where x equals base a to the y. Notice how on exponent this is our base, on logarithms that's our base. See here how y is my exponent? That is basically what I have here. So the way we're going to do this is the exponent. Let me come down to the bottom here. The exponent, when we're going to write it as a y, is what I have by itself. And I have it as an exponent. That's my exponent. And the base of a log is a number at the bottom. The base on exponents is that number at the bottom. So let's practice a little. To not get confused, I'm going to draw a little bit of lines here. So my exponent, in the first one, my exponent is 2. So I'm going to write 2 equals log base 3 of 9. See how I did that? Now looking at, let me skip to the third example. My exponent is 5. So I'm going to write 5 equals log base 10 of 100,000. Same thing I can do with from logarithm to exponent. I'm going to go, there's my base, there's my exponent. So I'm going to write this as 1/5 to the negative 2 equals 25. The way I'm going to write the last one, I'm going to do 4 to the negative 3. That's my base, that's my exponent. 4 to the negative 3 equals 1/64. Now we're going to solve for these. Now I have an x somewhere in there, so I'm just going to write this as in exponential form. There's my base, there's my exponent, so I'm going to say 4 to the negative 2 is equal to x. I know 4 to the second is 16, so 4 to the negative second is going to be 1/16 is equal to x. That's it. Looking at my example B, let me write it in exponential form. X to the second